Hello students, welcome to 7th lecture of Electrochemistry Competitive. So in previous lecture we discussed about some difficult questions, and these type of questions were not mentioned in our textbook. If you find any difficulty regarding to these type of questions, feel free to ask so that we can do same type of questions with different examples. Now let's see some other examples. So question is, salt of A atomic weight 7, B atomic weight 27 and C atomic weight 48 were electrolyzed under the identical condition using the same quantity of electricity. It was found that when 2.1 gram of A was deposited, the weight of B and C deposited were 2.7 and 7.2. The the valency of A, B and C respectively are. So in this question we have to find the valences of each atoms present here. So as per Faraday's law, we can say that equivalency of each element is equal to electricity passed through it. So we can say that suppose equivalency of A is EA, then it will be equal to EB and it will be equal to EC, and it is equal to electricity passed through the solution, which is equal to EQ. Q represents quantity of electricity in coulombs. And we know that how can we calculate it? Q is equal to IT, ampere multiplied by time. But here ampere and time were not mentioned. So these three values is the main values on which we will concentrate. How can we find the equivalency of each element? Now let us say first we want to find the value of EA. Now for that we need to find n value, that means number of electrons to obtain 1 mole of metal from 1 mole of iron. For example, for Cu it is 2 because Cu has +2 oxidation state and we need 2 moles of electron. So how can we find it? So first EA is equal to mass of metal obtained during the electrolysis, let us call it M, divided by atomic mass, let us call it AM, divided by n factor of given element or value. N factor, that means number of electron required. As mentioned, for copper it is 2. Let us say for metal A this n value is A. So same type of equation can be derived for remaining two, EB and EC. Okay, their mass obtained during the electrolysis divided by their atomic mass divided by n value. So our equation will be EA is equal to 2.1 divided by 7 divided by A, EB is equal to 2.7 divided by 27 divided by B, and EC is equal to 7.2 divided by 48 divided by C. So each of these values are mass of metal obtained during the electrolysis. All of these values are their atomic masses, and these are the n values, that means number of electron to obtain 1 mole of metal from their ion. And as we know, equivalency will be same. So EA is equal to EB and EB is equal to EC. So all of these values are equal. So you will get 0.3 A is equal to 0.1 B and is equal to 0.15 C. Now this value should be equal. As we can see, they are equal. So for that we need A is equal to 1, B is equal to 3 and C is equal to 2, because when we multiply 0.3 with 1 you will get 0.3. Similarly 0.1 multiplied by 3 is equal to 0.3, 0.15 multiplied by 2 is equal to 0.3. So these are the valencies of each metal present in our solution or electrolysis. So next question is for the electrochemical cell M to M plus X minus to X. Reduction potential of M plus to M is 0.44 and reduction potential for X to X minus is 0.33 volt. From this data one can deduct that now 4 options are mentioned. So each and every time if these type of questions are asked, then always remember to check this value. So as we can see here, first ionic state is mentioned or higher oxidation state is mentioned and then lower oxidation state is mentioned. So it is reduction potential. But if values are given like this, reduction potential M dash M plus. So this represents oxidation potential. First we have lower oxidation state, then we have higher oxidation state. Okay, so if these type of values are mentioned, then convert them into reduction potential. Sometimes mixed values will be mentioned. That means some are reduction potentials and some are oxidation potentials, but in this case both of them are reduction potentials, so no need to convert them. So higher oxidation state values always follows cathodic reaction. That means it will be reduced. So we can predict that our higher value, that means M, will always reduce. That means M plus 2 M by gaining electron. And lower reduction potential values will always oxidize. That means our value of our reaction for X should be increasing oxidation state. So X minus 2X, that means oxidation. So this should be our common conclusion. M plus and X minus should give M and X. Okay, so these options suggest our reaction should be option B. Mx will be product and M plus and X minus will be our reactant. Now what about the potential, cell potential? So let us try to find it as well. So as we know, our cell potential is reduction potential of cathode minus reduction potential of anode. So reduction potential of cathode is mentioned 0.44 and for anode it is 0.33. So from this data we can say that it should be 0.11, not 0.77 or minus 0.77. And electrochemical cell is mentioned, so it should be positive. If negative cell potential is obtained, then it will be electrolytic cell. Okay, cell potential of electrochemical cells are always positive and cell potentials of electrolytic cells are negative because we obtain reverse reaction by applying current. So now try to solve some other examples yourself. If you find any difficulty or if you find any different type of questions, feel free to ask. We will discuss them in detail. Otherwise, we will meet in next unit. Thank you.